Well, welcome back to the Cave of Science, and we're here looking at the homework for tonight, which I believe is the Chemquest worksheet 30. So the first problem we had was verifying using a periodic table and calculator that the molecular mass of dinitrogen pentoxide is approximately 108 AMU. And again, as we talked about in class, we're not going to use AMUs, so just consider it as grams. Alright, so let's look at the formula. We have NO2, so we have nitrogen, which we have 2 of them, oxygen, which we have 5. Looking at our periodic table, you'll see that nitrogen has an atomic mass of 14. So 2 times 14 will give us 28. Oxygen is 16. So 5 times 16, if my math is right, is 80. So if we add those two together, the atomic mass is approximately 108 grams. And again, I can't stress enough, take your time and write things out as you're doing these problems. The next problem says how many molecules of dinitrogen pentoxide are required to equal 108 grams. Alright, so we're going to use the factor label method here. So we want to get from 108 grams to molecules. So let's start with what we got. 108 grams of N2O5. I always like to put that over 1. One thing you should always do when you have something in grams, always convert to moles. That's a pretty good rule of thumb for everything here. So we need to find the molecular mass of N2O5. So we want to know how many moles of N2O5 are in 108 grams of N2O5. Then from there, we want to know how many molecules. Well, we already know it's 108 because we got that from the previous problem. So in 1 mole of N2O5, there are 6.02 times 10 to the 23rd, and we're looking for molecules. Of N2O5. And again, I know it gets a little redundant to write things out, but just get a good habit of writing things out here. Well, using the factor label dimensional analysis, grams of N2O5 are gone. Moles of N2O5 are gone. All we're left with is molecules. Multiply the numerators, divide by the denominators. Well, as we look at this, 108 divided by 108 is 1. So we're really left with, there are 6.02 times 10 to the 23rd molecules of N2O5. Or in other words, it's Avogadro's number is really what we're looking at there. Alright, let's flip it over, see what we got on the other side here. Let's see, that was 12, so I guess we are on 13. Why is the term molecular mass applied to water, but the term formula mass is applied to aluminum chloride? Well, molecular, when you talk about molecular, you're talking about the joining or compound of 2 nonmetals. When you talk about formula mass, it's really a metal and a nonmetal. This is going to be what is considered a covalent compound. And we're going to get into why that is called that later on. And this is considered an ionic. So that one is 13. Find the molecular or formula mass for each of the following, including the units. And again, really, there's not a whole lot of difference between molecular formula mass. You're still going to add up the masses of the atoms, multiply by how many there are, and then you're going to add them together. The only thing on this problem, you may have to Google a couple of these, and I'm not going to do every single one on here. But let's look at magnesium phosphide. If you just Google that, it's Mg3P2. Sodium sulfate is Na2SO4. And you got calcium nitrate here. And let's see the last one here. Oh, we've got C4H8. Well, all of these are going to work the same way, so I'm not going to do every single problem here, but let's just look at the first one. So for magnesium, we've got 3 of them. Phosphorus, we have 2 of them, and that's again coming from the subscripts here. And for magnesium, it ends up being approximately 24.3 grams. And for phosphorus, it's 31. And we can go 2 times 31 is 62. And 24.3, let me get my calculator. Let's see, 24.3. 24.3, and we've got 3 of them times 3 equals 72.9. I'll be honest with you, let's just round that up to 73, and we can add those 2 together. So let's just go 73 plus 62 equals 135 grams when we talk about the mass. All the other ones work the same way. Sodium sulfate, and I'm not going to write every one of these out. Sodium sulfate, we have 2 sodiums, we have 1 sulfur and 4 oxygen. Calcium nitrate, and again, we're going to use the distributive property here, so maybe I'll write this one out. Calcium, we have 1, and then you'd have to look up the atomic mass on your periodic table. This is like multiplying each of these. So 2 times 1 is 2. So nitrogen, we've got 2. And then 2 times 3 for oxygen is 6. So then we look on the periodic table, find the atomic masses, multiply by these numbers, and then add everything together. 15 works the same way. 16, really don't worry about. We're not going to get into that much detail in this particular class about that. So excuse me. So that takes care of those. All right, so let's look at the next problems. And we're looking at mole conversions on here. So we got, again, I don't know why they tell you to use your calculator, but you're going to have to use a calculator. You got 125 grams of gold, and you have about 3.82 times 10 to the 23rd atoms of gold. And we want to just show that that is the appropriate answer here. Well, the first thing we always do, if this is in grams, convert it to moles. So we have 125 grams, and gold is AU. I always like to put things over 1. And we got to convert that to moles. That's always the first step. And if grams in the top, grams go in the bottom. So 1 mole of gold is 197 grams of gold. And again, you would find that from the periodic table. And we want to get that into atoms. Well, when you start seeing this number, you've got to start thinking Avogadro's number. So in 1 mole of gold, there are 6.02 times 10 to the 23rd atoms of gold, AU. Well, if we go ahead, let me see if we straighten this out. There we go. Grams of gold, those are gone. Moles of gold are gone. So we're left with atoms. So if we go ahead and do the math, we'll find this times 1 times that divided by 197 is 3.82 times 10 to the 23rd atoms of gold. So that is correct. Let's look at number 18. So we got 210 grams of dinitrogen pentoxide. How many molecules are present? Well, first thing we have to do, we've got to get the atomic mass of N2O5. And so we have nitrogen and we have oxygen. We've got 2 nitrogen and 5 oxygen. We know nitrogen has an atomic mass of 14 from the periodic table. And we know oxygen is 16. So that's 28. And that's 80. So if we put those together, we find out it's 108 grams. You always, really, whenever you're given grams, you got to start thinking moles. Okay, so we're given 210 grams. 210 grams of N2O5. Now I always like to put things over 1. Well, we got to take this and convert it to moles. We know 1 mole of N2O5 is 108 grams. 108 grams of N2O5. And we want to know the number of molecules. Well, we're going to do Avogadro's number again. So 1 mole, excuse me, of N2O5 is 6.02 times 10 to the 23rd, and we want molecules. Of N2O5. So we got grams of N2O5 are gone, moles of N2O5 are gone. We're left with molecules. Multiply the numerators, divide by the denominators. And this equals approximately 1.17 times 10 to the 24th molecules of N2O5. Alright, let's look at problem 19. And again, we're kind of working back and forth in here. We're going from grams to molecules, and then molecules back to moles or back to grams. So if we got some CO2, we exhaled 7.25 times 10 to the 24th molecules. How many moles did we exhale here? So we got molecules and we want to go to moles. Grams don't even enter into the equation here. So let's write down what we have. 7.25 times 10 to the 24th molecules. Now I know this gets a little redundant trying to write things out, but especially at the beginning when you're learning, I would definitely write things out. And we want to get to moles. Well, we know in 1 mole of CO2, there are 6.02 times 10 to the 23rd molecules of O2, or CO2, excuse me. And again, the nice thing is molecules of CO2 cancel out. We're left with moles of CO2. So at this point, multiply numerators, divide by denominators, and that comes out to be about 12 moles of CO2. Once you start seeing the flow of these problems, they're really not too difficult. But the idea is, at least, especially when you're starting out, is to make sure you write things out. Because when you start writing things out in the factor label method, it leads you to the correct answer. And in B, how many grams of CO2 did you exhale? First, find out how many grams are in a mole by finding the molar mass of CO2. All right, so CO2, we've got 1 carbon. In oxygen, we've got 2. And carbon has a mass of 12. Oxygen has a mass of 16. So this gives us 12, this gives us 32, and that will give us 44. So there is the mass of CO2. Well, if we look at this and we want to know how many grams did you exhale, we're going to use this number of moles. So 12 moles of CO2, and again I like to put that over 1, and we know 1 mole of CO2 is 44 grams of CO2. So 44 grams of CO2. Well, we want grams, so we're pretty good. Moles of CO2 cancel out. 12 times 44, if my math is right, is 528 grams of CO2. And again, I keep repeating myself, but it's the procedure and the thought process. The numbers are going to change. Once you kind of get the thought process and the procedure down, the problems really don't become that bad. In a bag full of pennies, you have 2.15 moles of copper. How many grams do you have? Well, we're looking at copper, and we know we've got 2.15 moles of Cu. Again, I like to put that over 1. And 1 mole of copper is 63.6 grams of copper. Moles are gone. Moles are gone. I want grams. That's what I got left. Again, these are gone. So if you end up doing the math, and if my math is right, about 136.7 grams of copper. So that takes care of that worksheet. And again, I know it looks like a lot of writing, but again, believe me, if you start getting the thought process down and writing things out, it will lead you onto the correct answer. All right, that's it from the Cave of Science for this one.